Hi, my name's Shorful and welcome to another one of my videos where I talk about the real world of data. In today's video, a topic I want to cover off is a skill set that I think all data scientists should master, but is often overlooked. Okay. Now, when you think about being a data scientist, the skills that you think about are things like, can I build models, right? So you research and you run lots of different models, and you think that I can run everything from a predictive model, regression, or to a decision tree, to classification, to clustering. So you're focusing on that kind of stuff, or you might be focusing on data cleansing, which obviously takes up a lot of time for data scientists. So when you think about data cleansing, you might be thinking, how do I transform this data? How do I clean it from, if there's missing data, how do I impute the missing values? How do I get rid of outliers, that kind of stuff. But there's one skill set or one part of that which I think is quite overlooked, but is very important if you want to build very good predictive models. Okay, and that is feature engineering or feature extraction. Now, what I mean by feature engineering or feature extraction is that sometimes when you are asked to build a predictive model, you have very limited data set, and sometimes you're thinking, oh my god, how am I going to predict something with very limited data that I have? Okay, so I'm going to give you a very simple example. Let's say you have a table that has two columns. Okay, the first column is a transaction date and time, and the second column is a revenue amount. So at some time in the day, this amount of money was spent by a customer. Okay, so you've literally got those two columns. So where does feature engineering or feature extraction come into play here? Here, what you do is you take this date and timestamp and you think, how can I build more, or how can I extract more attributes from it or more features from it? Okay, so if you take the date, for example, so that date could be a weekday, it could be a weekend. Okay, it could be a public holiday, it could be a non-public holiday. Okay, so you could do that kind of stuff. It could be a sales day, so it could be like in the sales season, like Christmas, Easter, Mother's Day, Valentine, or it could be a non-sales type day. Okay, so you can do all of that. You can even look at your internal calendar and you can say that day happens to be on a day when we did a lot of marketing activity versus a day where we did little marketing activity or zero marketing activity. So now what you have is additional columns. Okay, so for that revenue number, you now have additional columns to predict it. So for example, you'd have a column that might say weekday 01 for that transaction, weekend 01 for that transaction. You might have was it a sales day 01? Okay, was it a promotion day 01? Okay, so you can start building lots of attributes. Same with the timestamp. Okay, you can start looking at things like, was it within working hours or non-working hours? Was it in the morning, afternoon, evening, nighttime, whatever it was? Create your own day part and you can start creating that. You can look at whether it was AM or PM, and therefore you've extracted. So in essence, you could take one one data type, which is date timestamp, and create 10 or 11 attributes from it. Okay, so that's what feature engineering is, because what that means is that now, where you had one variable trying to predict revenue, you've now got about 11 predicting revenue. So let me give you another example. Let's say you have something like product. Okay, so you've got, you're working for a retailer, let's say they're a supermarket, and you've got product. Okay, and you've got to find out, does product predict sales, okay, or basket revenue, whatever. Okay, now from that product you can look at things like, was it what category it falls under? So is it a fresh product, is it a frozen product, is it within a bakery, is it within butchers, whatever it is. Okay, you could look at the price of that product. Is it a high item price, medium item price, low item price? You could look at it in terms of weight. Is it high weight, medium weight, low weight, or whatever? You could have four categories. It doesn't really matter, but you would be having to do that. You would feature extract from that item and start doing that. Now that may require you looking at other things. It may even require you doing a bit of Googling, so you might, or even internal searching of your product catalog to see what the weight is, and you find all the weight of all your products and you go, you know what, I'm going to group them into 3 categories, 5 categories, whatever it is. But suddenly now you have product name, so that could be, let's say, Apple or something, and now you can categorize it. You can say, is it a fresh product, 10? Is it a frozen product, 10? Is it from the bakery, 10? Is it from the butchers, 10? So and so. Okay, weight, for example, weight, is it low weight, medium weight, high weight, 10, and so forth. Okay, so now you've extracted many more features from that one item. Okay, and that then helps you when you build the model, that the algorithm may pick up an attribute that is predictive of revenue. Okay, another example is, for example, let's take what's in a basket. Okay, so you might have the contents of a basket and you've got to predict, I don't know, does this person buy a certain product, or do they redeem a certain coupon, or do they respond to a certain promotion? Okay, so you look at the basket size and you think, what can I do? So here you may want to do more than just looking at the direct product. So you might want to infer things. Okay, so you might want to infer what kind of shopper it is. Okay, so is it someone on a budget? Is it a family? Is it a single person? Okay, just by looking at the item. Now there's no right and wrong answer here. What you're doing is using your intelligence to classify these things. Now the business may already have some kind of categorization. If they do, then brilliant, use those categorizations. If not, come up with your own. Okay, you might look at the products and you might also think, I wonder if it's a high value basket, a medium value basket, or a low value basket. You might also be able to look at the basket and infer an occasion. So you might say, oh, this just looks like a weekly shop, or actually this looks like a party, or this looks like for a barbecue, for example. So you may see items in there that makes you deduce that it's for a barbecue. Okay, but whatever you do, you've got to think about it and you've got to analyze that data, look at the data and extract features from it. Okay, because then what that happens is, like I said, if you're trying to predict whether they're going to take up a promotion, you've now got far more attributes that you can put into your model to predict whether they'll take up a promotion or whether they'll redeem a coupon, or whatever your business question is. Okay, so I hope I've given you an idea of why feature extraction is very important, and you'll come across this a lot. When you're working in a business, they may not have the data sets you want, okay, to predict the model, or the data sets they have is too limited and it doesn't give you enough to build a predictive model, okay? And what you don't want to do is say to the business, oh, can we not build this model now, let's build it in the future where we've collected much more data. You want to be able to see if you can extract more features from that data than is currently possible. Just to recap, why feature extraction or feature engineering is very important. One thing it does is it allows you to work with a limited data set, because now you can extract more features from that data and have a broader data set, okay, or a larger data set. The second thing it does, it allows you to pull more attributes into your model. So therefore, you may find there are features that are predictive of the thing that you're of interest, the metric of interest, okay, from all these features that you've extracted that may not have been evident the first time, or when you looked at the data the first time. When you're also feature extraction and then you build the model with those additional attributes or those additional features, you may find patterns that the business wasn't even aware of, okay? And then that becomes interesting, because now you've enlightened the business about something, or provide some insights into something that they weren't aware of. So let's take the promotion offer, right? They might think, oh, people who come in for promotion are one-off shoppers because we see certain so-and-so. But what you might find is that actually people who come in for those promotions are coming in because it's barbecue season, and therefore it related to them. So they would come in and they'd buy items that relate to a barbecue or to a party or something. So maybe the coupons work with partying rather than it being a one-off. So now you've got an idea, you can create a basket analysis and cross-sell and upsell more products for them. Okay, so that's essentially what feature extraction is. It's the ability to take a limited data set or a single data set and extract multiple features from that data set, so that you can put it into your model and have more attributes in your model to predict your metric of interest. With feature extraction, one of the things as data scientists you will notice is that this is very hard to automate. So it's very rare that machines or algorithms of AI will take over this. I mean, there's certain things they can do. For example, like the date stuff, they can map that across to say whether it's a weekend or a weekday, or whether it's holiday, non-holiday. But there'll be other things that they won't be able to do, which you'll come up with because of being human or because of your intelligence. So data scientists, if you can do this very well, it means that it's very unlikely that this skill will be automated, and therefore you become more valuable to the business. Right, so that's my advice to you. One skill set that I think you should learn as a data scientist is feature extraction or feature engineering. If you can do that very well, you'll find that you can work with very limited data sets and build far more powerful models, especially models that will be more predictive of what you're trying to predict. Well, thank you for watching my video. I hope you liked it. If you did, please do press the like button. If you have any comments or if you have any questions, please do put them in the comments sections below. Thank you very much.